Why does the universe grow into a giant cosmic web instead of a random fog of galaxies? In the energy filament theory, the shocking answer is that matter does not build the web at all. An underlying sea of energy first pulls itself into long, tense threads, and only then does matter slide down those tracks like dust settling into cracks. Look at deep space maps. Galaxies and clusters sit along bright filaments and nodes, like beads on an invisible spiderweb. Standard cosmology says matter clumps pull in more matter, and long filaments slowly form, which sounds reasonable but still treats matter as the thing that drives structure. Here the logic is flipped. Structure appears first in the energy sea, and matter simply follows. You can think of three invisible hands shaping the skeleton. The first hand is made of black holes, instead of being just cosmic trash compactors. They act like carving tools in the energy sea. Each black hole drags and tightens the sea around it from all directions, not as a single poke but as long stretches and pulls. And over very long times those pulls straighten and narrow the tension patterns into real lines. It's like pulling a huge rubber sheet from different sides, with enough steady stretching. Certain strips line up, thin out and become rigid ridges. Those ridges are the hidden skeleton lines of the universe. And with thousands or millions of black holes working across cosmic time, their ridges join, cross and merge into a vast lattice of tension strands. Galaxies do not decide where to gather from scratch. They naturally sink and stall along these pre-drawn corridors where motion is easiest and most downhill. The second hand is the averaged gravity of unstable particles. In some regions, short-lived particles are constantly being created and decaying, never letting the local sea fully relax. Each one, during its brief life, tightens the sea a tiny bit, and its decay releases that pattern back. But the never-ending sequence of tighten, relax, tighten, relax, time averages into a shallow but real gravitational base, like a long, soft dent in a tablecloth. That base does not decide where the skeleton lines are, but it keeps matters from wandering too far away from them. Sprinkle crumbs on a cloth with a groove, and they tend to drift into the groove instead of staying on the flat. The third hand is the background noise those same unstable particles generate when they die. Every decay kicks a tiny ripple back into the sea. Each kick is minuscule, but the universe is huge and the number of kicks is unimaginably large. Over billions of years, the superposition of these microjolts becomes a very gentle but persistent noise push that, on average, nudges anything slightly off the skeleton back towards it. It is not a gust of wind, more like an endless series of microscopic taps that, and statistically, favored sliding back into the tension valleys. Put these three together and the picture clears up. Black holes carve the skeleton filaments. The averaged pull of unstable particles holds matter near those filaments, and the faint noise from their death slowly herds stragglers back towards the same backbone. The result is a self-organizing cosmic web where the largest structures are the most stable, and smaller deviations are gradually washed back into line, all without needing a separate dark matter glue to tie galaxies in place. It also makes sense of why filamentary structure shows up very early in the universe. If the skeleton is written into the energy sea itself, it could exist before fully formed galaxies. So matter is born already sitting in or falling toward those strands instead of randomly wandering first and then stretching into threads later. The universe looks stringy not because matter likes to stand in neat lines, but because the energy sea has been pulled into long, tense filaments by black holes, supported by the averaged gravity of short-lived particles, and tiddied by their background noise. Matter is just the visible filling that slides down and settles along those invisible bones. Tap follow, share it on New Physics, Clear Universe.